Hello everyone, this is Gordon. We're going to begin a problem set on temperature measurement. We have on the right hand side relationships between degrees Fahrenheit, degrees Celsius, relationship between degrees Kelvin and degrees Celsius, relationship between degrees Rankine and Fahrenheit, and finally relationship between degrees Rankine and degrees Kelvin. Our first problem, ethanol boils at 78.5 degrees centigrade and freezes at negative 117 degrees centigrade at 1 atmosphere pressure. We're asked to convert those temperatures to the Fahrenheit scale, and in order to do that, we will use the second relationship excuse me, that we're given on the right hand side. And so degrees Fahrenheit will be 78.5 degrees Celsius multiplied by 9 over 5, to which we will add 32. And when we do the arithmetic, we get a numerical value of 173 degrees Fahrenheit. The freezing temperature we'll calculate the same way. Degrees F will equal negative 117 degrees C multiplied by 9 over 5, to which we'll add 32. And we come up with a numerical value, the freezing point for ethanol in degrees Fahrenheit, as negative 179. The second problem, mercury boils at 675 degrees Fahrenheit and solidifies at negative 38.0 degrees Fahrenheit at 1 atmosphere pressure. We're asked to express those temperatures in centigrade units or degrees Celsius. We'll be able to use the first relationship to solve this problem. So the boiling point of mercury in degrees C will be 675 degrees Fahrenheit minus 32. We'll take that answer and multiply that by 5 over 9. When we do the arithmetic, we come up with a numerical value of the boiling point of mercury in degrees C as 357 degrees C. The freezing point we'll calculate in the same way. Degree C will be negative 38.0, from which we'll subtract 32. We'll multiply the result by 5 over 9. And again, when we do the arithmetic, we get negative 38.9 degrees C. The third problem, we're asked to convert 40 degrees Celsius and negative 5 degrees Celsius to the Kelvin scale. We'll use the third relationship to solve this problem. Degrees Kelvin will equal then 40 degrees C, to which we add 273 to come up with a numerical value of 313 degrees Kelvin. The second problem we'll do the same way. Negative 5 degrees Celsius plus 273 gives us a numerical value of 268 degrees K. The fourth problem, express negative 22 degrees Fahrenheit in degrees centigrade and degrees Kelvin, centigrade of course being the same as Celsius. And in order to do that, we'll use the first relationship to get negative 22 degrees Fahrenheit into degrees Celsius. So degrees Celsius will be negative 22 degrees F, from which we'll subtract 32. We'll take that result, multiply it by 5 over 9, and when we do, we get a numerical value of negative 30 degrees Celsius. In order to convert that to Kelvin, we'll use the third relationship. Degrees K will equal negative 30 degrees Celsius plus 273. We'll get a numerical value of 243 degrees K. Our last problem, to convert 440 degrees Fahrenheit and negative 75 degrees Fahrenheit to the Rankine scale and the Kelvin scale. So we'll use the fourth and fifth relationships that we have over on the right hand side. 440 degrees Fahrenheit, to get that into degrees Rankine, we will add 460, and when we do, we get a numerical value of 900 degrees Rankine. the second half of the problem, degrees Rankine will equal negative 75 degrees Fahrenheit, to which we add 460, come up with a numerical value of 385 degrees Rankine. To convert these numbers into K, we multiply by 5 over 9, or degrees Kelvin. We multiply by 5 over 9. So we'll take 900 degrees Rankine, multiply that by 5 over 9 to come up with a numerical value of 500 degrees Kelvin. And the last one, 385 degrees Rankine, multiplied by 5 over 9, gives us a numerical value in degrees K, or degrees Kelvin, 214. And that's it. Thanks for watching.